Hello students, we are in assignment 10.6. The topic for this video is the expression for width of central bright in case of diffraction pattern due to single slit. For this topic, we will need to revise the condition for minima and then we will be able to find out the width of central bright. So let us start with condition for minima. As explained earlier, uh, when we are talking about the diffraction pattern of single slit, the central part is always bright, and we can explain it saying that at center the path difference is 0. So what is the path difference here? It is 0 lambda, and as you go up path difference increases. This is the point where path difference becomes lambda by 2. True here also. Okay, and then I can say that this distance is width. So if it is x and if this is marked as x, 2x is width of central maxima. Now from condition of minima, we know that for minima to occur, sine theta has to be n lambda by d. Okay, and first minima, if I am talking about, for first minima, n is 1 and theta is also small, so theta is lambda by d. Let this be first equation. So the figure is like this. This is theta and this is also theta. And let the screen distance be capital D. So if I apply tan theta formula, what is tan theta? It is x by d. See, for this triangle, if you apply tan theta, it is x by capital D. And considering theta to be very small, theta is x by d. Compare 1 and 2. So x by d is equal to lambda by d, and hence x is equal to lambda d by d. But for width, we have to consider 2x, and hence width of central maximum, that is 2x, is equal to 2 lambda d by d. So this is the expression of width of central maxima in case of diffraction pattern of single slit. Thank you.